Okay, this is the Algebra 2 study guide for Unit 4, Polynomials. Your guys' favorite so far, I'm sure. I really like this unit. But I'm going to warn you, on this test, you need to be very careful of your signs. Signs are so important. Watch your signs a lot, all right? So starting with number 1, they give you 2 addition problems to start off. So you just add straight down, pretty simple. Make sure you have like terms lined up, right? So the first problem is find the sum of 5x cubed plus 3x squared minus 5x plus 4 and 6x cubed minus 5x squared plus 4x plus 7. So you can see I lined them up. I made sure my x cubed, squareds, x to the power of 1, and my constants were all lined up perfectly. No problem. Remember, you're adding. So you're going to go 5 plus 6 is 11x cubed. Our exponents don't change. We're just combining like terms. We're not multiplying. So remember, don't add your exponents when you're not multiplying. All right, 3 plus negative 5. So plus negative actually means minus. 3 minus 5 is going to give you a negative 2x squared. All right, and then you have a negative 5 plus 4. So negative 5 plus 4 is going to give you a negative 1x. Remember, you don't have to show your 1. It's imaginary. All right, and then 4 plus 7. 4 plus 7 is 11. Make sure you put your signs, even if it isn't negative, you still have to have a positive sign. So your answer would be 11x cubed minus 2x squared minus x plus 11. All right, problem number 2. You can see here that they were missing the x squared here, the a squared. They had a cubed and a, so I left a spot so that we didn't end up with these lined up together, the a cubed and the a squared, because we don't want to add those. So add straight down. 5a cubed plus 0 is 5a cubed. 0 plus 3a squared is 3a squared. Now we have 4 plus negative 7, so it's actually 4 minus 7, which gives you a negative 3. And then a negative 7 plus 14. So negative 7 plus 14 would give you a positive 7. So 5a cubed plus 3a squared minus 3a plus 7. Now we have some subtraction problems for number 3 and 4. So in subtraction, it's a little bit trickier. Just make sure you say this minus this, all right? So the sign in front of it, we'll show you right now. So 14 minus 14a squared minus 15a squared. 14 minus 15 is a negative 1a squared, all right? Again, don't show the 1. Next, it's going to be 60a minus negative 31a. So minus negative gives you a positive. So 60 plus 31a is a 91a. All right, and last you have a negative 5 minus positive 8. So negative 5 minus 8 is going to be a negative 13. So the same thing here on this problem. This one they do decimal numbers. 8.3 minus 7.4. So pretty straightforward. 8.3 minus 7.4 is going to give you a 0.9 x squared. All right, next is 0.9 minus negative 1.7. So it's actually 0.9 plus 1.7, which is going to give you a positive 2.6 xy. All right, and last, 3.6 minus 6.4. So 3.6 minus 6.4 is going to be a negative 2.8. All right, watch your signs when you subtract. All right, we're going to do some multiplying of multiplying of binomials. I can speak. All right, so the first one, 2 binomials multiplied. They're not any special cases. They don't match. They're not perfect squares, anything like that. So we're just going to multiply using FOIL. So remember, FOIL is first, outer, inner, last. All right? So first terms, then your outer terms, and then inner terms, and then last terms. All right? First, outer, inner, last. All right, so our first terms are 7x and 5x. So now we're multiplying our exponents, add when we do that. So 7 times 5 is 35, and x times x is x squared. outer terms are going to be 7x and 3. So 7 times 3 is 21x. Inner terms, 5 times 4, 5x times 4 is going to give you a 20x. And last terms, 4 times 3 is 12. Got ahead of myself. All right, and then to finish this off, we need to combine our like terms. This should be 20x. All right, so you have 21x plus 20x. They're like, so 20 plus 21 is 41x plus 12, the end. All right, problem number 6. If you look closely at this problem, you'll notice it is a special products. All right, so we did these. We had a couple lessons about special products. These look exactly the same, but one's positive and one's negative. That means the middle terms are going to eliminate when you multiply them. So when you do this, that look exactly the same with different signs, you just have to square the first term, which would be 16x squared, x to the 4th. And the last term, which is going to be 49. Ooh, having trouble writing today. 49, and it's always minus in the middle. And you're missing your middle term because you would get a negative 28 plus 28. All right, so those would eliminate completely. Number 7, if you look closely, it's also a special products. You have x minus 4, and then the first term squared here, the two terms multiplied in the middle, and the last term squared. So it's minus plus plus. That means our original was these two cubed, x cubed, and this cube. 4 cubed is 64. And we always keep our sign. All right, so remember a binomial and a trinomial is a perfect cube. Numbers 8 through 10, we work on our division skills. All right, on problem number 8, it is 4m squared minus 10m minus 24 divided by 2m plus 3. Now, unfortunately for this, we cannot do synthetic division because we have a coefficient on the first term. So we have to do long division, all right? So, first off, what do we have to multiply 2m by to get 4m squared? So we need to multiply by 2, and we need another m. So we're going to multiply by 2m. So 2m times 2m is 4m squared, and then we have to go 2m times 3, which will give us 6m, a positive 6m. Subtract this. These eliminate. Negative 10 minus 6 is a negative 16m, and we're going to drop the 24. All right, now what do I have to multiply 2m by to get negative 16m? So we need to multiply by a negative 8. Negative 8 times 2 is negative 16m. Negative 8 times 3 is a negative 24. And both of those will cancel. Whenever they have the same sign and you're subtracting, they cancel. All right, so your answer is 2m minus 8. Now another one after this. This one, they say divide 5x squared plus 6x minus 9 into 25x to the 4th plus 19x squared minus x minus 78. All right, so we're dividing 25x to the 4th. And if you'll notice on this, they give you an x to the 4th, and then the next term is x squared. So we're going to go ahead and put a placeholder of x to the 3rd in here. All right, and then we'll put plus 19x squared minus x minus 78. All right, and we're dividing this all by 5x squared minus, plus 6x minus 9. All right, so 3 terms at a time. All right, so I don't know why I wrote 4 here because I know it's 5. Okay. So what do we have to multiply 5x squared by to make it equal 25x to the 4th? So we need to multiply the number by 5, and then we have 2 exponents, we need 4. So we need 2 more. So we're going to multiply it by 5x squared. So 5x squared times 5x squared is 25x to the 4th. All right, next, 5x squared times 6x is going to give you 30x to the 3rd. And then 5x squared times 9 is going to give you a negative 45x squared. Let's subtract this. These two are going to eliminate. 0 minus 30 is a negative 30x cubed. And then 19 minus negative 45 is actually a 19 plus 45, which is actually 64x squared. All right, drop the negative x there. All right, what do I have to multiply 5x squared by to get a negative 30x to the third? So to get 5 to equal 30, I'm going to have to multiply it by a negative 6. I have 2 exponents. I need 3, so 1 more x. All right, negative 6x times 5x squared is a negative 30x cubed. Negative 6x times positive 6x is a negative 36x squared. And last, we have a negative 6 times a negative 9. 2 negatives make a positive 54x. Subtract again, these two eliminate. 64 minus negative 36. So minus negative is positive. 64 plus 36 is 100x squared. Negative 1 minus 54 will give you minus 55x minus 78. Okay, what do I have to multiply 5x squared by to get 100x squared? So 5 times 20 equals 100. 20, 40, 60, 80, 100. All right, so plus 20. We want a positive 100. We already have both our exponents, so we don't need to multiply by x. 20 times 5x squared is 100x squared. 20 times 6 is 120x. Well, 6x is 120x. And 20 times negative 9 is 180. Negative 180. Subtract this. You have 100x squared. Those eliminate. Negative 55 minus 120 is going to be negative 175x. And negative 78 minus negative 180. So negative 78 plus 180 would be negative 102. That's your remainder, so you're going to put it up there. You're going to say plus negative this over 5x squared plus 6x minus 9. All right? Ooh, that was a big problem. Next, one more division problem. This one is 3x squared plus 7x minus 16 divided by x minus 3. So yay, we get to do a synthetic division because there's no coefficient on the divisor. All right, so we're just going to use our numbers 3, 7, and 16, negative 16. And it's x minus 3, so we're going to use a positive 3 right here. All right, remember to do this. You drop this number first, 3, then you multiply. 3 times 3 is 9. 9 plus 7 is 16. And 16 times 3 is 48. All right, then negative 16 plus 48 is 32. So you're going to take your one exponent lower than your dividend had to start with. So it was 3x squared. So we're going to go one lower. So your answer is going to be 3x plus 16. And then this is going to be your remainder plus 32 over x minus 3. On the score key, I think they just have it written R and the number. This is how it is in the blue boxes in your curriculum. All right, so don't think you have it wrong. If it just says R32, it's still the correct answer. Problem number 11 is going to start us on some factoring. All right, so number 11, they say factor to lowest, factor completely, then place the answer in proper location. All right, so you need to say, is there anything common in these terms? 6a to the fourth, 8a cubed b squared, and 4a squared b cubed. So yes, 2, right, goes into all of these. Also, each term has at least an a squared. The first one has a to the fourth, second one has a cubed, and the third one has a squared. So they all have an a squared in them. They don't have a b because the first term does not have a b in it. So what is common in all of these is 2a squared. So we're just going to divide each of these by 2a squared. So 6 divided by 2 is 3, and then we took a squared, so you only have a squared left. 8 divided by 2 is 4, and we took 2a, so it's just ab squared. And last, 2, and we took the a squared, so all you're left with is b. That's the end of that problem. You're not factoring farther down from there. All right, problem number 12. They give you a trinomial 9x squared plus 3x minus 20. All right, so first you check, is there any common terms? 9 and 3 are both divisible by 3, but 20 is not. So no, you're just going to have to factor it from here. So you need to take your factors of the first number, which are 9, 1 and 9, and 3 and 3. And your factors of the last number, which are 1 and 20, 2 and 10, 4 and 5. And you got to figure out how to multiply one number by one of these, the other by the other, and end up with a 3 in the middle. So this one, I'm going to say we're going to go 3 times 5, which is 15, and 3 times 4, which is 12, because 15 minus 12 is 3. All right, so these are your first terms. So write your two sets of parentheses. You're going to have a 3x and a 3x. Okay, then you can put the 4 or 5 either place because they're both 3's, but you want to multiply the 3 by the 5 and then the 3 by the 4 to get 12. Now, when you have a negative and a positive in here, positive, negative, it means you're going to have one of each. If they're both positive, you're going to have two positives. If it's negative, positive, they're both going to be negative. But when you have a positive, negative, you're going to have one of each. So how you have to think of it is, I need a positive 3. So my bigger number, when I multiply, I have 15 and I have 12. My bigger number needs to be positive because I want it to be a positive. So I want a positive 15, then minus the 12. So I'll get positive 15 minus 12, and in the end, I'll get a negative 20. If you want a negative number, you want your bigger number to be negative. All right, problem number 13. So check it out first. Is there anything common in these that can be removed? 3 goes into 9, 3 goes into 12, 3 also goes into 45. So let's take a 3 out, and we'll end up with 3x squared minus 4x minus 15. All right? So our factors of 3 are 1 and 3, and our factors of 15 are 1 and 15, and 3 and 5. And this is a negative, negative. So again, we're going to have one of each on a negative, negative. All right? How are we going to make 4 in the middle? So what I say is you go 3 times 3, which would give you a 9. And a 1 times 5 gives you 5. 9 minus 5 is 4. That's what we're looking for. All right, so these are your first terms. You want to go 3x and a 1x. All right, and then you want to multiply the 3 by the 9. So, the 3 by the 3 to get a 9. So that means the 3's go all the way over here. So outer, they can do 3, and then the 5's going to go here. So you're going to get a 9 and a 5. All right, your middle term, you want it to be negative. So that means your bigger number, which is 9, needs to be negative, and you're going to add the 5. Negative 9 plus 5 is negative 4x. You put your 3 in front right here. Now on the study guide score key, I know that this is not the right answer, but I'll tell you why. It's because they didn't take out the 3, and they should have taken out the 3. So what I have put here is the correct answer. Continuing with factoring on problem number 14. So if you look, is there anything common in these terms? 16 and 56 are both even numbers, so they're divisible by 2, but 49 is not. So no. The next thing you're going to look at is, are my first term and my last term perfect square roots, all right? Yes, they are. 49 has a square root of 7, and 16 has a square root of 4, and it's plus plus. So this is a special product. You can just take your factor of this number, your square root of this number, which is 7a, plus the square root of this number, which is 16. So sorry, it's not 16. Square root of 16 is 4b, and it's going to be squared. All right, so pay attention. Check for perfect squares because they're way easier to deal with. Number 15, it's another special product where we are missing our middle term. When we're missing our middle term, we know, oh, we had exact, but one was positive and one was negative. So you just have to take your square root of this and put it here and here. And the square root of this, 5b, here and here. All right, so when it's smaller, you actually get bigger in perfect squares. Number 16, we have, this is called the difference of two squares, all right? The same thing here, but first we want to deal with the 25 goes into 25 and 100. So So before we ever factor, we can take out the 25 and be left with a to the 4th minus 4. Why did I put 5? 4b to the 8th. Now we still have a perfect square, right? The difference of two squares, which means we're going to have a positive and a negative. A squared goes here and here because that's the square root of a to the 4th. Square root of 4b to the 8th is 2b to the 4th. 2b to the 4th. All right? All right, continuing with factoring. Number 17. So if you look at this, is there anything common in all of these terms that can be taken out? 14, 68, and 48. Well, they are all even numbers, so they can at least be divided by 2. And I think that's the biggest number because 3 doesn't go in here, or it's only 2 and 7. 7 doesn't go into 48 or 68. All right, so let's take out a 2. We're left with 7a squared minus 34a plus 24. All right, now let's look at it again. Is it a perfect square? No and no. So we'll have to do it the hard way. Your factors of 7 are 1 and 7. Your factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. All right? All right, so obviously our first terms are going to have to be the 7 and the 1. And how are we going to make 34? So 7 times 2 is 14, and 1 times 12 is 12. 14 plus 12 would be a 26, or 14 minus 12 is 2. So that doesn't work. We're looking at 34. 7 times 3 is 21, and 1 times 8 is 8. 21 plus 8 is 29. 21 minus 8 is 14. I'm sorry. All right, so last 7 times 4 is 28, and 1 times 6 is 6. 28 plus 6 is 34. All right, so those are the two we're going to use. So our first terms are going to be 7 and 1. So we're going to have a 7a and a 1a. And then what do we want to multiply our 7 by? We want to multiply it by 4 to get 28. So this has got to go all the way over here, and the 1's going to multiply by the 6, right? And it's negative positive, so this is 1a. I don't know why I have a 1 there. 7a and 1a. Negative, positive, they're both going to be negative. Don't forget your 2 in front because we took that out. All right, and number 18. Again, another trinomial, 12x squared minus 36xy minus plus 27y squared. So is there a common factor in all of these numbers? They're not all even, so not 2, but 3, I believe. 3 goes into 12 4 times, into 36 12 times, and into 27 9 times. All right, so we're going to factor the 3 out. 3, we're going to be left with 4x squared minus 12xy plus 9y squared. Ooh, I think what we have here is a perfect square. 4 has a square root of 2. 9 has a square root of y. It's minus plus, so they're both going to be minus. Your square root of 4x squared is 2x. Your square root of 9 is 3y. And so minus plus, they're both minus. There's going to be 2 of them, and you've got your 3 out in front there. One more factoring problem, and then we're going to move on. Factoring a perfect cube. So this is m cubed minus n cubed. Remember, a perfect cube factors to a binomial times a trinomial. All right, your binomial just takes the cube roots of these numbers. So the cube root of m cubed is m, cube root of n cubed is n, and you keep whatever sign's in here. So it's going to be minus. When you have a minus, that means both in here are going to be plus, plus. If you had a plus, it would be minus, plus. All right? For your trinomial, the first term is the first term of the binomial squared. So m squared. The middle term are these two multiplied, which would be m, n, and the last term is the last one squared. That's simple. All right? All right, moving on to direct and inverse variation. They give you this equation, xy equals c, and they ask if this, what kind of variation is this? So remember, when x and y are in a ratio of multiplication, that's inverse variation, right? So this would be inverse, and when they're divided, this is a simple way to remember it. It's direct. All right, and then here we have X and Y are inversely, and Z is directly inverse. So that makes it a combined variation. You have direct and inverse variation. Problem number 23 says, if X and Y vary directly, so that means X over Y, and X is 12, sorry, is that what it says? X is 12 when Y is 6, then find the value of X when Y equals 9. So you're looking for this, just write a little proportion. X is 12, Y is 6. What is X when Y is 9? So you're just going to cross multiply. 9 times 12 is 108. And X times 6 is 6X. So all you got to do to find this answer is divide 108 plus, divide 108 by 6, and you'll have your answer. Number 24, this is the last problem. The rate traveled from Amarillo to Austin by a bus averages 60 miles an hour. The bus arrived in Austin after 5 hours of travel. An automobile averages 50 miles per hour. Using the inverse variation relationship, show what time would be the best show what the time would be for the automobile to complete the trip. So remember, in rate and distance problems, rate times time equals distance. That's why we're using the inverse function, because we're going to go rate times time. He traveled 60 miles an hour for 5 hours to get to one spot. How many hours does a guy going 50 miles an hour have to travel to go the same distance? So their distances are equaling. Rate times time equals distance, and rate times time. So you just multiply 60 times 5 and then divide by 50 to solve for X, and you'll have your answer. All right, I think we saw that the heaviest part of this test is going to be your factoring. So really study up and know how to factor. All right, and I hope you all do wonderful on the test.